Area of a triangle. In earlier classes, we have computed the area of triangle by using the formula area of a triangle is equal to 1 upon 2 into base into altitude. In this section, we will find the area of a triangle in terms of the coordinates of its vertices. We can find the lengths of three sides of triangle by using distance formula, and then we can use the Heron's formula. But this becomes tedious, particularly when the lengths of the sides are irrational numbers. That is why we prefer to compute the area in terms of the coordinates of the vertices of the triangle. In the following theorem, we state and prove the same. Theorem: the area of a triangle, the coordinates of whose vertices are x1, y1, x2, y2 and x3, y3 is 1 upon 2 modulus of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Proof: plot A with coordinates x1, y1, B with coordinates x2, y2 and C with coordinates x3, y3 in the Cartesian plane and join them. Draw AL, BM and CN perpendiculars from A, B, C on the x-axis. Clearly, ABML, ALNC and BMNC all are trapeziums. Area of trapezium is equal to 1 upon 2 into sum of parallel sides into distance between them. We have area of triangle ABC is equal to area of trapezium ABML plus area of trapezium ALNC minus area of trapezium BMNC. Area of triangle ABC is equal to 1 upon 2 into BM plus AL into ML plus 1 upon 2 into AL plus CN into LN minus 1 upon 2 into BM plus CN into MN, which implies area of triangle ABC is equal to modulus of 1 upon 2 into y2 plus y1 into x1 minus x2 plus 1 upon 2 into y1 plus y3 into x3 minus x1 minus 1 upon 2 into y2 plus y3 into x3 minus x2, which implies area of triangle ABC is equal to modulus of 1 upon 2 into x1 into y2 plus y1 minus y1 minus y3 plus x2 into minus y2 minus y1 plus y2 plus y3 plus x3 into y1 plus y3 minus y2 minus y3, which implies area of triangle ABC is equal to 1 upon 2 modulus of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Alternate method. The area of triangle ABC can also be computed by using the following steps. Step 1. Write the coordinates of vertices A with coordinates x1, y1, B with coordinates x2, y2 and C with coordinates x3, y3 in 3 columns as shown below, and augment the coordinates of A with coordinates x1, y1 as 4th column. Step 2. Draw broken parallel lines pointing downwards from left to right and right to left. Step 3. Compute the sum of the product of numbers at the ends of the lines pointing downwards from left to right and subtract from this sum the sum of the product of numbers at the ends of the lines pointing downwards from right to left. That is, compute x1 y2 plus x2 y3 plus x3 y1 minus y1 x2 plus y2 x3 plus y3 x1. Step 4. Find the absolute value of the number obtained in step 3, that is, modulus of x1 y2 plus x2 y3 plus x3 y1 minus y1 x2 plus y2 x3 plus y3 x1. Area of triangle is equal to 1/2 modulus of x1 y2 plus x2 y3 plus x3 y1 minus y1 x2 plus y2 x3 plus y3 x1 square units. Collinearity. 3 points A with coordinates x1, y1, B with coordinates x2, y2, and C with coordinates x3, y3 are collinear if and only if area of triangle ABC is equal to 0. That is, x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 is equal to 0. Or x1 y2 plus x2 y3 plus x3 y1 minus x2 y1 plus x3 y2 plus x1 y3 is equal to 0.